All right, let's start by doing a little bit of review. We'll go back to some velocity and acceleration and displacement. Okay, so we have this function here that's a velocity function. So we have the velocity is 2t squared minus 11t plus 12. We need to write down an expression for the acceleration. Well, I know that acceleration at t is equal to the derivative of velocity at t. So I'm going to do the power rule, which gets me 4t minus 11. Okay, so then part B, wait a minute, we wrote down the expression in terms, yep, that was it. And now what we need to do is the particle is moving to the left between two values, A and B. We need to find the values of A and B. So what I'm going to do is there's two pieces here. Left means that my velocity is going to be negative. So what I'm going to do is I'm going to find the critical values for velocity for when time equals 0. Okay, that's acceleration, but I'm going to find the critical values for velocity when time equals 0. And that's either going to be, the first one's either going to be A or B, the second one's either going to be A or B. And to figure out when it's moving left, I need to find out when the velocity is negative. So we're going to take velocity for part B and have it equal to 0, 2t squared minus 11t plus 12. And we're going to factor this. And we're going to factor this without a calculator. So I need A times C is equal to 24. That's 2 times 12. And B is equal to negative 11. I need two values that multiply to 24 and add up to negative 11. And I see negative 8 and negative 3. So I'm going to substitute those back in. So I have 2t squared minus 8t minus 3t. And that replaces the negative 11t plus 12. I'm factoring by grouping here. Okay, and then I'm going to pull out the common factor in the first two terms. I see it as 2t, and that leaves me with t minus 4. And the common factor in the second two terms I see as negative 3, so that leaves me with t minus 4. So my factors become t minus 4 and 2t minus 3. So my two critical values are at time equals 4 and time equals 3/2. So one of these is A and one of these is B. What I need to do is figure out my sign diagram to figure out which one is which, basically. So I'm going to put the smaller one here, 3/2, and I'm going to put 4 here. And I'm going to test values in all three of those areas. So a number that's less than 3/2 would be 0. That's an easy one to test. So when I put 0 into my velocity function, I get 0 minus 0 plus 12. So that gets me a positive number. A number that's larger than 3/2, that's easy, would be 2. So I put 2 in here. 2 squared is 4 times 2 is 8. Okay, so I've got 8 plus the 12 gives me 20. And then I put 2 in here and I get negative 22. So that would be negative 2. So that would be a negative value. And then I'm going to test the number after 4, which would be 5. So t squared would be 25 times 2 would be 50. So 50 minus 55 would be negative 5 plus 12. That's a positive number. So I know that it is moving to the left when velocity is negative, and velocity is negative between those two values. So it is moving left between 3/2 and 4. So that tells me that A is equal to 3/2 and B is equal to 4. Okay, so that's a nice little warm up there. Next, I just want to make sure that we review real quick some derivative rules. Okay, we have our constant rule. So the derivative of any constant number is equal to 0. So what that is saying is the derivative of, say, 5 is equal to 0. Okay. The constant multiple rule means that if we have a constant in front of a function, we can actually pull that function out front, pull that constant out front, and then just find the derivative of that function. So if we were looking at 3x squared, that would be the same as 3 times the derivative of x squared, right? So the 2 would come out, so that would be 3 times 2x, or 6x. The other way to look at it would be to take the 2 times the 3 and just turn it into 6x, using the power rule for both of those. Okay, sum or difference. If we're adding two functions together, we can take the derivative of them individually and still add them or subtract them. Product rule, we take the original function multiplied by the derivative of the second function, add to it the second function multiplied by the derivative of the first. Quotient rule, we do the second function times the derivative of the first minus the first function times the derivative of the second. So that's backwards from the product rule, but we have a minus sign in there. And we take the second function and we square it. And then we have the chain rule, which is what gets used most of the time, basically, where we take it's a function inside a function. So it would be like the chain rule, let's say 3x squared. What it's saying to do is take the derivative of the whole thing. So that would be 2. We relist what the original inside was. We bring this down to 1, but then we multiply by the derivative of the inside, and the derivative of the inside is that. So what we're actually looking at here is 6 times 3, 18x would be the derivative of that one. So just a quick review of those rules, and now we're going to go into an investigation. So you need to make sure you have a calculator for the next video. Either you can use Desmos, use your, you need a graphing calculator, I should say, or if you have 84 at home or something like that, something where you can actually graph a trig function and make sure it's set on radians.